so you say that's how you remembered it, but then you're like, wait, I didn't remember it.
All right.
Is that actually what that's saying here? Is that just coincidence?
We went over it when we did try this for the first time.
Yeah,
I think someone brought it up.
Douglas,
Hmm.
is the derivative of the area being the circumference of a circle, is that a coincidence or is
I don't know, but it's so weird because it's true for surface area and volume too. It's got to be a thing,
yeah, for real right there?
right?
The law of Mason.
Okay.
No, it's gonna be the law
Mason
of
does
Mason.
not want to major in mathematics though, so he won't do well.
Okay, so we're going to talk about how do you find the exact value. So all the things except the area that we talked about yesterday, right? Let me back up. Definite integrals. Area under a curve. X times y is y varies. 3 ways to estimate. What are they? Count the boxes. Trapezoids. Riemann, which is rectangles, right? Okay. He's so random. Okay, we talked about those properties, and then yesterday with the area, that is a way to get the exact value, which works fine if you have a graph. But what if you don't have a graph? What if you have a function? Okay? Like our warm-up from yesterday where I was like, here's a function, find, estimate L sub 4. Well, we don't do that in real life because there's a way to do it. Exactly. There's a way to do it exactly. So that's what we're going to talk about today. How do you get the exact value of a definite integral? Okay, and it's something called the fundamental theorem of calculus.
Seems like a big deal.
You think?
The fundamental theorem.
I know.
Fundamental theorem is the fundamental.
I feel like we should have learned derivatives in pre-calc.
Part 1, because there are 2 parts of this.
Oh boy.
Okay, and they're both fundamental. Yeah, I know. Okay, so
Is it like the Viking drill of calculus?
Has the rest of the year just been like introduction?
yes, now it's the important day, the one important topic.
Miles, you gotta use 80% of the tissues in here. I'm the other 20.
I've used my own fair share. Okay, so first of all, let's talk about what this means before we go any further. Also, why we reviewed this today.
Is that an approximate equals or is that a fully equal?
That's a fully equal.
Okay.
Why is that capital?
Okay,
No, I said
that's okay. That's why we're going to talk about it.
it stands for fundamental.
Totally. Okay, so we got a little f, big F, which sometimes... Garrett, why are you making fabulous eyes at Joe? And Joe, why are you not face forward? Okay, we're seriously talking about something that's really important, so pay attention. So what is this much asking you for?
It's the
Antiderivative. So it's just saying we're going to use the antiderivative of little f, and we're just going to call it big F. That's all. That's all that means. Okay? Big F. Think about going it backwards, right? So we've made it from small to big.
So is big F just the antiderivative of little f?
Did I not just say that?
Yes.
I did. Okay.
That's my question.
Can I call my antiderivative just big F?
Yeah, but just put an equal sign.
Are you ever gonna phrase a question where it's in that notation where it's asking for big F?
No.
Like,
No, but you will see this kind of a thing on the AP test. They'll be like, hey, big F is the antiderivative of little f. The indefinite integral. Hello? Oh my gosh, seriously? Yeah, do you need them right now? Yeah, that's fine. Okay, bye. Miles!
I knew this guy always finding ways to miss class.
Always find a way to miss my class. So I can make sure the door's unlocked, okay? So you can get back in.
He's coming back.
She just needs you for a quick. She just needs you for a quick minute.
He's definitely class.
Oh, what class can you miss?
Probably my calculus.
Yep.
I might independent study Spanish, where we do nothing.
Okay.
Shorthand for if and then, because we read them a lot.
Yep.
Really short, but like.
It should just be a symbol. That's like when people abbreviate sorry without the O. That's all.
Well, they duck off one of the R's.
Yeah, that's all.
Yeah, that's true. Okay, so we have to remember in a math definition, you're going to use some things. If you're going to use it later in the definition, you have to define it. So that first mathy thing there, after the if, the so long, hard to write if, is just defining what capital F is. So capital F is telling you it's an antiderivative. So this piece gives you the conclusion. If you want to find the definite integral, then you take your function, you do what with it, big F, you do the antiderivative, and then you do f of b minus f of x, top minus top.
Talking about making words shorter and everything. If you're writing like a paper for college.
No, don't abbreviate.
Okay, I was just gonna say like don't
Don't.
and do not. Because if
So
I
one's
want words
casual.
for a word count,
Also true.
I can say do not.
Oh, please. And they preferred not contractions because it's not considered formal writing. So you want to go formal, no contractions. Also, it gives you extra word count.
I don't think I'm going
Okay.
college, but I was just wondering.
Garrett.
If we're supposed to find the intervals, how are we supposed to plug both?
Observe. So here's an example.
Yeah, every time.
And if at the same on the same hand, if you are like, I have too many words, don't use cannot. Cannot can be one word.
Yeah.
You go with that.
You're really struggling if your contractions are contributing this much to your word count.
Dude, contractions.
It's going through the least amount of words.
Put out an extra
Part of writing a
sentence
good
in the
paper is
little
making sure it's concise. No one wants to read a 10-page long paper about something that isn't 10 pages worth of information.
Just repeat the same sentence and say it a different way.
I don't know, what's the word count at some point?
It's easier to just separate your contractions and get like 2 more sentences.
Okay, so here you go. So this is what this looks like. Actually, it won't say use the FTC to find it. If I'm not going to say that after today. If you're going to find the exact value, you're going to use the fundamental theorem. Also, notice it doesn't give you any information about, hey, I want you to estimate this using L sub 7 or whatever. Okay, so super easy to do. To do this, you do the antiderivative. So what's the antiderivative of 3x squared? Okay, x cubed plus c. Now, this has a little bit different notation to it. This is not freaky notation. We need to somehow indicate that we need to plug in the 10 and the 4. So we use this straightened out line.
Bro, it's just a straight line. Why do you say what?
No, because the S indicator is the integral indicator. So we already did the integral. So if you want to imagine that you straighten the integral out because it's done, do that. Mason?
That'd just be like if we were writing it as a function, be like f of x and we just plug in 10 for the x, like.
Yeah. So
Just not having to write it twice.
yes, exactly. So this is going to be 10 to the third plus c minus 4 to the third plus c.
So the C's cancel out.
Okay, so just hold on a second. Mason, what's your question?
Does this notation work? Like sometimes we would do things without f of x, we would use y instead.
Yeah, absolutely. Yep. Yep.
Like if x
Yep.
equals this.
I've seen that a lot on the AP test, actually, where like you're doing a derivative at a certain value. You can absolutely use that. Okay, so 2 things. You do this math. This is 1,000. Okay, 64. What happens to this C if it's in the parentheses here? Because you're subtracting all of this, right?
This gotta be raised.
Distribute there, Avery. Okay. So then final answer, you do your subtraction is 936, I think. and you're done. Now, here's the beautiful part about this. Okay, listen very carefully. This business with the C's always happens, so you don't have to write them when you're doing a definite integral, because the C's will always cancel. So,
There's never like a three-way.
nope. So this would be like, if I wrote this, I would write it like this. 10 to 4. Okay? You're not going to ever, the C would always cancel because it's going to be two things. You're going to subtract top minus bottom. C's will always cancel. Don't write the plus C here. The deal is, though, that you have to remember that if you're just doing a straight indefinite integral, that needs the C's, like we did on our warm-up. Okay? So you just want to watch out for that. Okay, so fundamental theorem, not difficult. Okay, so I would like you to do, let's do the integral from 0 to 2 of, I'm going to still be nice to you, 4x plus 1 dx. You did. Like, it's literally called the fundamental theorem of calculus, and you missed it. You'll be fine. Just copy it. It was a long trip for a mint.
What?
I heard that there was like.
Yeah, there's a lockdown at Grant, so we're in a.
Oh. Good. Oh, I wonder if that's an email that I got because I'm
We're
read
in
my
a
email.
secure mode.
Do this. That's why then.
They won't even tell the kids at Grant.
Oh.
Yeah.
Let's see what I know from my.
Yeah, I tried
Email.
this situation.
Oh no, I don't even have that. How do you know, Caleb?
Snapchat gets around quick.
Snapchat.
Yep.
Real quick.
I'm sure because Alice works at the Christian school, and so she got like a message.
Yeah.
Hi, you are doing this, please.
Did I say +1?
Yeah, plus 1 dx.
couldn't tell if it was one of those lines.
Nope, that would only be, that line will only come after you do the antiderivative.
Does the line have an
only
angle
work
with it?
if you're, does the line only work if you're plugging in two different values?
You could do one.
It's really.
So you could do like, let's say I said, hey, I want you to find derivative of y equals 6x, that's squared plus 4x, and then find, I don't know, the y value at x equals 1. You could do dy dx, and then be like 1.
So are we combining this with the
Because you're just
rules?
plugging in
Yeah.
1 to the derivative.
It's easier than changing it to like the stuff form.
You don't have to, you can. Here,
Will that line always have the numbers to the right of it?
yes, always.
So are we combining these with the rules we learned yesterday?
You don't need to.
No, not for this one, but I'm asking, is that something we do?
This is supposed to give us
Oh,
an answer.
are we supposed to combine that with the rules?
Yeah, I got that.
There's, okay, pause. Let me show you how you would do this one. Okay? What's the, think of this, the difference between what we did yesterday and what we were talking about on the warm-up is that this is one function, right? The other ones, when we're talking about them, is f of x plus 4. That's like two separate things. So treat this as one function. What's his antiderivative? 2x squared plus x. We're going to evaluate that at 2 and 0. Okay? Plug in the 2. And what do you get?
10.
Yep. Plug in the 0. And what do you get?
0.
Super easy. And so the answer is 10.
So you always do the top one minus the bottom.
Always. Top minus bottom. Now,
How do you get 10 from that? 10 minus
just plug 2 in.
No, you didn't ask what was 10 minus 0.
Okay? So 2 squared is 4 times 2 plus the 2. That's the 10. Because I plug 2 in for both of the x's.
Yeah.
Then I plug 0 in for both the x's. You good?
Yeah.
Okay. Now, so I'm not sure if this is what you were asking me yesterday, but watch what happens. Also, if you didn't like yesterday's rule with the constant thing, watch this. You can separate these. Now, I will tell you why I would not in just a sec. Okay? It's just more work is really what we got going on. Okay? What's the antiderivative of 4x? So this is 2x squared from 2 to 0. What's the antiderivative of 1?
It's 1 over x.
Try again.
0. Wait, no.
It's just x from 2 to 0. Okay? So you could look at you. It's totally going to be the same thing. So why would you do it? It's downstairs, right? Okay. Let me say this though. If you did not like what we were doing on the warm-up, let me bring that back up and show you this. Okay. You now, if you're looking at the warm-up, could do on the bottom, if you're splitting it up, you could be like, hey, 4 and 7, you still have to do that first part of the work. But the second one, now that you know about the fundamental theorem, you don't have to remember that formula anymore. Because you can do the antiderivative of this. What's the antiderivative of this?
4x.
Good. 4x from 7 to 4. Okay, you're gonna get the same. You're gonna get the same thing because this is gonna be 4 times 7, which is 28, minus 4 times 4, which is 16, and that gets you the 12 that we got. I don't have that other formula memorized because I do it this way. This makes sense to my brain. And then that's one less thing I have to remember.
So you mean like with those tables and graphs and stuff that we would go in the package as long as we had the equation, we could use this formula
Absolutely.
and figure it out.
So
From piecewise though.
correct. So if it was piecewise, then you could do if you had part of it, you could do the fundamental theorem on the part that you have the function for.
What if it's not, but if it's not continuous? So you can only do it on part?
Piecewise and continuous.
It would be piecewise and continuous. It's got to be continuous. To do the integral, it has to be the continuous period. Okay, so I would, anyway, this I think answers your question. I would not split them up because it's the same. Okay, you don't have to split it up if it's like an f of x and then a 4 like that. But let's talk about this. Let's say you have the integral from 4 to 1 of, I'm going to make life easy again. Let's see if we are going to do 2x minus 3. Now, here's what I want. If you are born in an even month, okay? Like your number of your birthday month, right? You with me? Because you know there's people in this world that would be like, they're not numbers. Yeah, they are. If you're born in an even month, I want you to not do anything, and I want you to follow the fundamental theorem, top minus bottom. Okay? If you're born in an odd month, realize that this is backwards, right? It's backwards, so I want you to do this. Okay? So odd month people, you're going to do the bottom one. Even month people, you're going to do the top one. I want you to see what happens. Okay?
Wait, I think I know.
Just do it when I asked you to do.
Because you always do the top one first.
All right.
But maybe I'm wrong.
I did 190.
Did anyone actually do the stuff they're supposed to put in the hallway? Is that yours? I don't think mine's it. I feel like I was supposed to do something that you just like downstairs. Is everyone supposed to do something? I don't think I was supposed to do something.
There's an NHS meeting, there's a softball.
I know, there are so many meetings.
It's not even like the golf coaches.
You guys get -6.
Avery, I like your socks.
Joe, if you're not going to do my math, Joe, if you're not going to.
I just heard Avery say what his answer was. So he's done.
Yeah, but it derails everybody else. Cut it out.
Yeah, okay, when you get it.
I don't know. We don't, you and I. I had to think about that. It's like, wait.
Okay. So both shush. Both of you have to do the antiderivative. Okay? What's the antiderivative of the function? Okay? X squared minus 3x. We don't have to have the c, right? Because the c will cancel. So if you went from 1 to 4, you plug in 1, you should have -2 minus 4 is what? 4? Should have -6. Now, if you went this way, you also have x squared minus 3x from 4 to 1. Yeah, I don't know. This is 4 minus -2, right? Which is 6, and then apply the negative. So you apply it at the end because you multiply it when you're done. Or you can distribute the negative to your function, right? You have negative x squared plus 3x, that will work also. So this property, the property of the switching one, doesn't matter for if you're doing the fundamental theorem because it will work itself out, but you always have to do top minus bottom if you're going to get the right answer. Okay?
So the right answer is -6.
Because that's both correct. Yeah.
Hypothetically speaking, if we were to like on a test, get the ones that aren't this way, but you do it this way, do you get any points or is it just straight 0 points on that?
I will never give you an equation, and I guess that's not true.
Yeah.
I'm gonna guess, I can't remember what my test says, that I'm not gonna do like the warm up yesterday, right? Are you talking about like the warm up yesterday where I was like, here's an equation, find. Can you stop? I'm talking to Caleb. Don't interrupt.
I'm talking about like, if I did the fundamentals,
The fundamental theorem.
yeah, this theorem on everything, I know I would get them wrong, but would you get some points?
What are you gonna do without an equation? How are you gonna do it without an equation?
How are you gonna do it without an equation? Right.
If it's a table, how are you gonna use this?
Correct.
You won't, but what if, like the ones that were on the home, the one that was on like
Don't do that.
The one that was on the warm up today wouldn't have been able to be done by this and it wasn't a table.
Because it was an indefinite integral. So it's this, honestly, it's the same process, except you don't have the a and the b to do, right? So it's just the equation and you're done. The second problem, no, you can't. There's no way to do
And
it.
you can't do that on this either because you just have A and B then.
Because you have a and b. Yeah, yep, David.
I was confused because that says 4 minus -2, and that's 6, not -6.
Because I put the negative on.
Can you show the work? Because I did something wrong with it.
Okay. Did you put the negative in at the beginning or at the end? Beginning. So that would be negative and then positive, right? Okay, so if you plug in the 4, that's -16 plus 12. Minus, you have to minus both. So it would be minus -1 plus 3. Both have to be subtracted.
Oh my goodness. I did put it.
Okay, there you go. Okay. Questions right now on this? Hopefully it does not seem too hard. It's not supposed to be too hard. We will practice this a little bit more tomorrow. Talk about what happens if you have an absolute value equation and then have homework. So hopefully you have a lot of homework time tomorrow. That's my goal.
Tomorrow, like short class at 5